Hi, this is Atay Rabbi and you are watching YouTube. Today we'll talk about properties of salts. In this video, we'll cover salt and their association with acids, importance of water for salts, and their water solubility. So we want to know about salts and their properties, but we'll start from their definition. Like, did you know that salts are children of acids? Not literally, but yes, salts came from acids and they are all ionic compounds. Now that's interesting because this means you can literally deduce salts from the formula of acids. Usually they have two types of ions, a cation or positive ion and an anion or negative ion. The hydrogen part of the acid, when replaced by any metal or ammonium ion, will produce salt. So the anion part of the acid is staying with the salt. Let's observe some acids and their anion parts, like hydrochloric acid with chloride ion, sulfuric acid with sulfate ion, nitric acid with nitrate ion, phosphoric acid with phosphate ion, and carbonic acid with carbonate ion. So they must be producing chloride, sulfate, nitrate, phosphate, and carbonate salt. Just for a case purpose, let's assume we want to replace hydrogens with sodium. And what we get are sodium chloride, sodium sulfate, sodium nitrate, sodium phosphate, and sodium carbonate. See, all these are sodium salts. Pretty amazing, right? You can try this by taking any metal. Take a metal like sodium, potassium, magnesium, calcium, or lead. Now replace them with hydrogen and see for yourself. In case you are thinking about ammonium ion, which is not a metal but can also replace the hydrogen part. Let me help you here. Same thing happens when we replace hydrogen with ammonium. We get ammonium chloride, ammonium sulfate, ammonium nitrate, ammonium phosphate, and ammonium carbonate. Now you get the picture, right? Let us now explore a little bit more about their physical property. You see, salt can combine with water to form hydrated crystals. When no water molecules are combined, we call them anhydrous salt. But when they do, we call them hydrated salt. These water molecules have name of their own. They are called water of crystallization. Usually they have no impact on chemical properties, but they affect some physical properties of salts. Take copper sulfate for example. When anhydrous, it is a white powder, but when hydrated, copper sulfate forms a blue crystal. Similarly, magnesium sulfate and sodium carbonate also have their hydrated forms. So water is an important part of salt. Okay, so we now know about salts. We just need to know about their preparation in laboratory. For this, it is essential to know about their solubility in water. We're going to need this property to extract them after preparation. Generally, salts are soluble in water, except some. Just remember them, like barium, calcium, and lead chloride, barium or lead iodide, barium, mercury, and lead sulfate. For carbonates, however, all carbonates are insoluble except sodium, potassium, and ammonium carbonate. Okay, that's all for today. Hope you guys enjoyed this video. If you have any question regarding this topic, leave me a comment and I will try to answer. See you later. Take care.